Hey there! Turn on your speakers. Do you have finals week coming up? Projects due? Homeworks are piling up? Are you freaking out that you're getting boxed in with deadlines? Here's an idea. Get help. Think Geek Exams. Find us on Facebook, Twitter, or YouTube.
So this is the fifth and last problem in the R project sequence, and this video is going to be probably split into two because it's a pretty big problem. We're going to do regressional analysis on a data set that we download from the internet. The website is given here. We are told to choose a data set, and here's the website over here, and we can see that there's a whole bunch of data sets over here. I have gone through a few of them until I found one that I like, and the name of that one is MPG. It's miles per gallon for fuel economy data from 1999 to 2008 on 38 popular models of cars, and it needs to have so it says true here. That means numeric data is available and character data is available. It's got some binary data and no logical data. So that's the situation. So I downloaded the CSV file. The explanations for the different fields are given here. So it's got the manufacturer model name, engine displacement, year, cylinder numbers, transmission type, then what kind of drive it is it front, rear, or four-wheel drive. Then there's the dependent variables, which are the city miles per gallon and highway miles per gallon. Then there's more character data types, which are fuel type and class or type of car, like is it sedan or different types. So we're not going to look at all of that data. We're going to look at just a few of them. First, we want to decide that these. Okay, let me show you what the data set looks like. We want to decide that these two are probably going to be. We need one dependent data, but this one has two. So city gas mileage and highway gas mileage, and the rest of these are independent data. So we are going to compare. First, we're going to take the manufacturer as an independent data. It's a character independent data, and we are going to study that with the city and highway. So let's do that in our So let's do that. So I have already written the code, so I'm going to run it and explain what I'm doing. We need ggplot for this, so I'm going to run that. Then we need to import the data. So this code does that. It's basically doing read.csv, and that's the file path and the file name, which I downloaded from the internet, as I showed. And this one compares highway mileage with respect to manufacturer, and it creates the ggplot, and this is what it looks like. So we have the manufacturer names at the bottom and the highway mileage on the left. So basically we can see that depending on the manufacturer there is some variance and there is some correlation. But we cannot really, it's not really linear, so we cannot really tell which manufacturers are doing well. We can say that, okay, Honda is doing well, but we cannot group them. It's cumbersome because they're not in a linear fashion. Linear only works with numerical data, but this we could do better than this. So I'm going to close this and show you the city versus manufacturer, city mileage versus the manufacturer plot, and that looks sort of like this. It's the same thing here. We see that different companies have different city mileages, and it looks like there is correlation between city mileage and the manufacturers. We've also in both these plots, what I've done is I have grouped the different cylinders. So you can see that the top ones, the highest mileage ones, are 4-cylinder cars, and the lowest mileage ones are 8-cylinder cars, and the mid-range ones are 6 cylinders and 5 cylinders. So that's how this is labeled. What we want to see now is if we can order these manufacturers so we can get a linear picture. So this line of code here orders them. I have just manually ordered the names. So basically Land Rover on the left, Lincoln, Mercury, Jeep, Dodge, and then I take the most efficient cars and put them on the right. So Toyota, Hyundai, Volkswagen, and Honda on the right. So let's see how that works out. I'm going to run the plotting code again, and this is for the highway data. And yes, so there is some linear correlation over here. So basically high gas mileage cars are over here. So these are economic cars, so they do well per gallon. These are your gas guzzlers. You can see that these are mostly 8-cylinder cars. I'm sorry about these. Oh God. All right, these are 8-cylinder cars, and these are your 4-cylinder cars over here, and these are your 6-cylinder cars in green. And overall, it looks like it's pretty linear between highway mileage and a manufacturer. We're going to do the same thing with the city mileage cars. Let's run that, and pretty similar. Pretty similar. They're behaving the same way in city mileage. The higher fuel economy cars are on the right, and they are doing well in gas mileage. The gas guzzlers are doing poorly on the left, and the mid-range cars are in the middle. They're right around here. You could draw an imaginary line, which you cannot do with categorical data. I tried to turn the categorical data into ordinal data. That's why you're seeing this linear trend, but you cannot draw a line between categorical data with numerical dependent variables. So, but we can picture it. So that's what I've done. But what we've noticed is our two graphs between city and highway mileage, they sort of had correlation, and they're both dependent variables, but they had a correlation. So let's look at that correlation. So here we see a very distinct linear regression line that can be drawn between the city mileage as the dependent and highway mileage as the independent data. This is a dependent data, but we're trying to see the correlation between the two, and there's a high correlation between the two. You could draw a pretty distinct line between them, and that's interesting. So we're going to stop this video today, and we're going to pick it up in part 2, where we basically do linear regression between city and highway and engine displacement data. They're both numerical, so all three are numerical. So we can do a pretty good analysis, regression analysis, using those and see where it takes us. Thank you very much. See you in the next video.
Think Geek Exams. Our agents have Masters of Engineering degrees from MIT, Stanford, Georgia Tech, Caltech, We give you solutions to mathematics, physics, computing, and engineering. Find us on Facebook, Twitter, or YouTube.